Hello, this is day 15 from chapter 12 sequences and series, and this is binomial experiments. So we just covered Pascal's triangle and expanding a binomial. So we'll use some of that. How many ways are there for 4 friends to go skiing this weekend? So let's just say there's, you and 3 others, and the 4 of you are either gonna, some are gonna go skiing, some of you aren't. Maybe all 4 of you are, maybe none of you are. And we're just going to figure out how many different ways there are. And each of you are unique individuals. So, just for the sake of ease, let's just number you off. It'd be 4 people. So 1, 2, 3, and 4. So if the question was raised, who's all going skiing? This is the situation right here where all 4 people raise their hand and say, I'm going skiing. And there's only one possible way for that to happen. Because everybody is going skiing. There's only one possible way, and that might not make a lot of sense yet, but it should in a second. So let's say that then only 3 of you are going to go, and one person says no. So maybe it's person 1, person 2, and person 3 that says yes, they're going, and then one person, the last number 4, says no. Okay, that's a group of 3 people going and 1 person not. And then you could have a different situation where first 2 people say they're going, third person says no, but the 4th person says, yeah, I'm going too. So it's still 3 people. So this is a group of 3, and you can see the different arrangements of the person not going. Person not going could be the second person, the person not going could be the first person, and that is all possible ways for 3 people out of the 4 to go. And there are 4 total possible ways. Same thing with 2 people and 2 people. It could be going, going, not, going, going, not, going, not going, not going, not going, not going, going, not, or going, not going. And there are 6 possible ways for that to happen. Okay, so now look at the significance of this pattern. We have 2 opposing variables. They're the opposites of one another. And essentially there are 4 people total. And so the outcomes, the total possible outcomes for all of these ends up basically just following going, not going binomial to the 4th. Because there's one possible way, that's your coefficient going to the 4th, plus 4 possible ways of 3 goings and 1 not going. Notice it's following the same pattern that we had before, where your first variable starts off at the exponent of 4 and then goes in decreasing order as we count down. That's a 6. This is a G. They look the same, I'm sorry. The next term would be 6G to the second to n to the second. And that's where 2 are going and 2 are not. So the exponents kind of represent how many of each group fit this category. G n to the 3rd, and there's one way for all 4 people to not go. They all just simply decide not to go. So that's pretty awesome, the way that this actually kind of relates to essentially combinations. So we see that it was this guy in Pascal's triangle that we used. All right, let's try an example. So let's say you flip a coin 5 times. How many times will you get exactly 4 heads? How many times will you get at least 4 tails? Okay, so there are 2 opposing things on a coin, heads and tails. And then we raise it to the 5th time because we are to the 5th exponent because we're flipping it 5 times. So you get heads or tails, and you're doing it 5 times. So how many times will you get exactly 4 heads? How many times will you get at least 4 tails? I'm gonna change this to how many ways could you get exactly 4 heads? And same thing here. How many ways could you get exactly 4 heads? Because we're not guaranteed anything, and we're flipping a coin 5 times, multiple times, then it's kind of presupposing. So in any event, here's what we were thinking of. We're flipping a coin 5 times. How many different possible ways could I end up with getting exactly 4 heads? So for instance, it could go heads, 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 tails. That would be 5 times, and I got 4 heads. It could go tails, and then the rest of them heads. That would be 4, and so on. So we have a number of different possibilities of outcomes here. So that's going to be this row of Pascal's triangle because it's raised to the 5th power. So we have 1, 5, 10, 10, 5, 1. And I can start filling this out. I'm going to fill it out backwards just to show that you can do it. But we don't really need to do this. We need to know that this is the way it would look if we needed to do it. But it's not that necessary. So I'll just stop right there. Well, I could keep going. I'm using the same system. I just went backwards. The reason why is to not give away this first answer too quickly. How many ways could you get exactly 4 heads? So all we're looking for is which of these terms is going to be have the h to the 4th power. And if it's the term that has h to the 4th, then it's also the term that has t to the 1st. This basically means you got heads 4 times and tails once out of those 5. So the term that gets that one would be this term. This is the h to the 4th, t to the 1. This first term is h to the 5th. This next term would be h, 3, t2. Now I've listed them all out, but now it's easier to see. Obviously, it would be this one. There are 5 different ways to get 4 heads and 1 tails. So our answer for this is simply 5. There's 5 different ways. How many ways could you get at least 4 tails? So this least here kind of tricks us a little bit. That means that to fit this to fit what they're asking, at least 4 tails means that you could get 4 tails, or a situation where you got more than 4 tails. As long as you got at least 4 tails, that's what we're saying is a success for this question. How many ways could you get at least 4 tails? So the terms that have t to the 4th or higher is this one and this one. So there are 5 ways to get 4 tails, and there's 1 way to get 5 tails. So that would be 6 ways to get 4 tails. At least 4 tails. All right. So basically, you need 2 opposing things in a problem, and you need to know how many times they're happening. And then you make a binomial to that power, expand it, and then answer the questions about the terms. That's binomial experiments for us. So in a cancer treatment group of 10 people, how many different groupings are there of at least 3 that show improvement? Okay, so this could get ugly. We have 10 people, and there are at least 3 people that show improvement. So that's what we're asking. We're asking, we need to count up the ways in which people show improvement, and then so the 2 opposing things then are improve or not improve. So I'm just kind of labeling, I'm defining what I'm talking about. So if we had a binomial, there's people are either going to improve or they're not improve, and there's 10 people. And so if I started writing this out, this is the 10th row. Oh my gosh. You can see how many terms that is. So let's just start with a couple. 1, 10, 45, 1, 10, 45, 120, 210, and 252. So this is the middle term, 252. You see that? That is the term that's going to be, it's symmetric, right? So that's right in the middle. That's the term that's going to be 5 and 5. So I to the 5, n to the 5. That's where half of the people improved and the other half did not show improvement. Okay, so let's just see what the question's asking. How many different groupings are there of at least 3 that show improvement? So we're looking for any term that has I to the 3rd or more, because it's at least 3 that show improvement. Okay, well, we can fill in some of these if I want, just to see where we're at. But I didn't write all the terms down. I stopped at 252. That's the middle. The first term would be I to the 10th, obviously. So that's obviously at least 3. And then I went all the way to the middle and I got I to the 5. That also is included. So certainly all of these are included so far. The next would be 210. And then the next one after that would be 120. And then 45, 10, and 1. So and this last one is going to be all, n to the 10th. This is I, n to the 9th. So I'm going to fill in a lot of these. I mean, you don't have to fill them in all. Like, obviously, I know that this span is all in the success group so far for our criteria. This would be I squared, n to the 8th. This would be I to the 3rd, n to the 7th. And the bell should be ringing right now. I to the 3rd. How many different groupings are there of it? At least 3 that show improvement. So this is the 3 that showed improvement. This would be 2, so that's not at least 3. So I can't count these ones because they're all less. I has an exponent less than 3. But at least 3 means 3 or more. So certainly this one, and then this would be I to the 4th. So that one, that one, that one. So all of these numbers. So this is how many different ways. If it's at least 3 to show improvement, then all of those will count. So we got to start adding them up. I'm doing this briefly. 1 second. If I put everything into the calculator right, I got 968. Okay, and these are our combinations. No, keep in mind, this is 968 of one of the ways. One of the ways would look like, out of your 10 people, it could be improve, not improve, not improve, not improve, not improve, not improve, 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 not improve, and improve. This certainly counts. I have 4 improves, so that's at least 3. So this would be one of the ways, and I just kind of randomly generated it. Hopefully there's 10. So that's what we're talking about, a group of 10 people. And, certainly this one would count too. This would be somewhere in there. I. Were they, 5 of them, 6 of them, 7 of them, 8 of them, 9 of them, and 1 didn't. That would certainly be included as well. So it's really just making Pascal's triangle, or using Pascal's triangle to expand a binomial, and your binomial is created by the 2 opposing situations, improve or not improve in this case. All right, I hope this helps, and good luck.